Using Java library can be challenging at times because there may be multiple ways to do the same thing. A recursive directory traversal is one of those things. In my next demo, I created a class named DirectoryVisitor, which extends Java library SimpleVisitor. This SimpleVisitor has a method named visitFile, which we can override in our class. In addition to this, we can also override the method named visitFileFailed, which gives you an opportunity to do something about a file in your directory that for some reason you don't have access to. For instance, it may be already opened and logged by another program in a multi-user environment. Anyway, in our case, what I do here in visitFileOverride, the method takes two parameters, the path, which is nice, and already a set of basic file attributes that you don't even have to construct yourself. Just use the combination of attributes that you need in your code. Yeah, it was added because so many Java programs needed exactly this kind of way to access items in a directory, so here it is. At the end of this method, we can return various constants, such as continue. We can also say skip siblings to continue without visiting the subdirectories, or you can skip subtree to continue without the process at the previous, higher levels of this directory. And of course, you can also stop the iteration by returning a terminate constant. Okay, in the main program, I call visitDirectoryItems, which takes the initial path as a parameter. And the entire directory traversal process is set off by calling the static method named filesWalkFileTree, which is taking the initial directory path and the reference to the subclass of the SimpleFileVisitor. From this point on, everything is happening automatically. We will get the calls to visitFile method for every file that can be located anywhere in the hierarchy of the directories as specified by the user. But notice one difference here. If we use the walkFileTree method in the files utility class, as we call it right here, the walking starts at a given path and everything is done for us recursively, but what we get in the process is only files. No directory items appear in our output compared to the previous demo runs. This is because in our case of subclassing the SimpleFileVisitor, only visitFile is overridden by our DirectoryVisitor class. If you need to include directory items in your walking process, you can also override visitDirectory methods of the SimpleFileVisitor. In fact, there are two methods available called pre-visitDirectory and post-visitDirectory. So you can choose what to do before and after the directory listing is fully processed. All of this is very helpful if you're trying to design an algorithm to populate a tree view control, such as the one here in my file manager window. But that's a completely different story. Okay, finally, the demo number 4 does exactly the same thing, but instead of the DirectoryVisitor class, the methods overrides for visitFile and visitFileFailed are written in line using the anonymous class syntax. So the syntax is identical to our DirectoryVisitor class, but here everything is written in line, starting from this brace to here to this anonymous class closing brace. And I wanted to show you this way as well, because if the methods are really short and the class such as DirectoryVisitor has no data attributes. Many Java programmers like to use the anonymous class syntax, which spares the project of extra source Java files like our DirectoryVisitor example, especially if this is the only place where such class is needed by the entire application. In a very large project, anonymous classes may spare the project of the need to have dozens and often hundreds of classes that would have to be included in the project if anonymous class technique wasn't available in Java language. Okay, that's all I have for this demo. You can play with any of the methods I showed you to adopt in your model view controller implementation of assignment 7, finding the largest file in a directory.